Now we're going to simplify algebraic expressions. We start off with something called identities. These are equations that are always true, so you can use them to deduce what's true about things or not. For example, x plus y is y plus x. The order of addition doesn't matter. X times y is y times x. Again, the order of addition doesn't, of multiplication doesn't matter. They have a fancy name for it. They call this the commutative law. When I heard that name, I always think of these numbers are in teeny little cars running back and forth. And between you and me, although zooming is spectral, because it's really sort of like a seance. It is it is it is kind of intimate, and I got to tell you, I do not miss commuting, but I digress. This is the associative law. It's how you bracket things together. X plus parent y plus z and parent equals parent x plus y, that plus z. And it doesn't matter, it's just x plus y plus z. You add them all three together. Similarly with multiplication, x times parent y plus z and parent equals parent x times y and parent times z. And again, it doesn't matter, it's x times y times z. So it doesn't matter which way you bracket them. If you take x and add 0, it's x. If you take x and times 1, it's x. So plus 0 does nothing to x. Times 1 does nothing to x. These are called identities. They keep x identical. Watch out, though. Adding 0 does nothing. Timesing 1 does nothing. So as far as multiplication is concerned, 1 is like a kind of nothing. And I've seen people mistake these two for that reason. So when you cancel everything in a fraction and nothing is left, well, the result is 1, not 0, because it's multiplications doing nothing. Here, x plus its opposite is 0. Okay, this is a little bit trickier. X times its reciprocal, 1 over x, is 1. But dividing by 0 is a problem, so I have to add that x is not, if x is not 0. So this is a law with an exception. Now, each of these rules, times and plus and times, are acting pretty much the same law, really. A little bit different here with a 0 and a 1. And a little bit of problem here with dividing by 0, but still these are basically the same kinds of laws. But this next law treats times and plus differently. X times a sum, y plus z, equals the sum x times y plus x times z. This is called the distributive law. It's as if this x is being distributed over these y and z. I think of it in terms of geometry. Here's a rectangle with one side x, the other side y plus z. This area is x times y plus z. But if you take this rectangle and snap it along this line here, so you have two rectangles, one x by y, the other x by z. So the area here is x times y plus x times z. And that's what this is, the distributive law. It implies what's called combining like terms. You have ax plus bx, that's a plus b times x. The idea of like terms, like this and this, or this and this, these two are like terms because they have the same variable, x. 3x plus 4x is 3 plus 4 times x. You have a minus 7y minus 2y. Again, these are like terms because they have the same variable y. And pulling out y by distribution, it's negative 7 plus negative 2 times y. So these will all add up to 7x minus 9y. Here's 3x plus 7x minus 4x. These are like terms. They all have the same number, variable x. You remove it from the, you remove it by factoring. Then you get 3 plus 7 minus 4, all that times x, and these add all up to 6. So therefore, 6x. Here's a nasty one. 3x squared y plus 4xy squared minus 7x squared y minus 2xy squared. Like terms, it's not just the same variables, it has to be the same variables to the same powers. So here's 3x squared y, here's minus 7x squared y. These are like terms. So you get 3 minus 7 times x squared y. Here's a 4xy squared, Here's a minus 2xy squared. They're like terms, they're like to each other, but they're not like to the other two. So we pull out a xy squared. That times a 4 minus 2 here. So 3 minus 7 times x squared y plus 4 minus 2 times xy squared. And then, okay, it's negative 4, positive 2. Therefore, negative 4 x squared y plus 2 x y squared. The idea of these general rules is we can use them to simplify expressions. So for example, negative 4 times 8r times negative 2y. Rewrite that simpler. Well, because of associativity, we can forget all the parentheses. So we negative 4 times 8 times negative 2 times r times y. So we drop all the parentheses and shuffle the constants and variables around. Negative 4 times 8 times negative 2 is a 64, so you get 64ry. You have negative 4 times minus 3t plus 5. Now here the idea is we distribute the negative 4 over these two terms. So you get negative 4 times negative 3t here, plus negative 4 times 5 here. Okay, this multiplies out to 12t. This multiplies out to negative 20. So 12.
Why did you put the 3t? Why did you put the 3t in parentheses and not the 5?
Okay, I could if I wanted to. You're right. Convenience, that's all.
Yeah, I mean.
Minor convenience.
Okay.
You have a point. It's a minor convenience. Okay. And of course, you can, of course, be careful when things convene because you might slip a little. In this case, it's not. Yeah, I could have dropped the parentheses. I guess because I didn't want this negative right next to the times to look like I was subtracting or something. That can get confusing. Use parentheses or not, whichever way is clearer, because that's the important part, being clear. Now here we have a whole complicated expression. And we have to do what I call breaking a vase in order to glue it back together again. I'm going to do a bunch of distributing in order to combine terms. Here we go. Negative 3 times p minus 2 plus 2 times p plus 3 minus 5 times p minus 1. What is that? Oh boy. Okay, multiply negative 3 times p minus 2. You get negative 3p. Negative 3 times negative 2 is plus 6. And yes, I was skipping a step or two there. Here's 2 times p plus 3. That's 2p here. 2 times 3 is plus 6. Minus 5 times p is negative 5p. Negative 5 times negative 1 is positive 5. You have to be careful about double negations. All right, great. Now you have a minus 3p, 2p, negative 5p. So you pull out a p times negative 3 plus 2 minus 5 times p. And then you have constant 6 plus 6 plus 5 here. So this combines to negative 6p. This combines to 17. Negative 6p plus 17. So I distribute, then combine, or as I said, break a vase door to glue it back together again. Now here are some examples. 100 times 0.9x plus 0.02y. What is that? We'll distribute the 100 over each of these two terms. You get 100 times 0.09x plus 100 times 0.02y. 100 times 0.09 is 9. 100 times 0.02 is 2. So 9x plus 2y. Now here we have negative 9a plus 11ad minus 35a plus ad. We need to be, okay, we want to combine like terms. Negative 9a minus 35a, that's negative 9 minus 35 times a. Now here, watch out for this. 11ad plus ad. Okay, great. But watch out. ad equals 1 times ad. There's a nothing next to the ad. But that's not a 0, that's a 1. So this is going to be 11 plus 1 times ad. All right, so combining these, you get negative 44a plus, and this will be 12ad. Like that. This one's nasty gnarly. 24 times 5 6y minus 9a. Ugh. Minus 24 times 3 24ths y. What is that? Oh boy. So you multiply 24 times this and times this. and multiply negative, well, 24 times this. And so here we go. 24 times 5 is 6y. It gets multiplied into the numerator. 24 times 5 over 6 times y. Minus 24 times 9 over 8. Minus 24 times 3 over 24, it's y. All right, now here things get a little gnarly. 24 over 6 cancels, leaves a 4, times 5 is 20. 24 over 8 is a cancels, leaves a 3, times 9 is a 27. 24 over 24 cancels, leaves a 3. So we're going to get a 20y for this term, minus 27 for this term, minus 3y for this term. Now we combine two like terms. 20y minus 3y, it's 17y.
Smokey, come.
Yes?
Smokey. Smokey. Smokey.
Is that your cat? Don't worry, I'll be interrupted by it. I'm surprised that Charlie hasn't shown up and rubbed my face with his tail to demand attention yet. He will. All right, here we go. 17y minus 27 is what this is. OMG. Oh, what a serious mess. 2 times bracket 6 times parent, a third a plus 2b, n parent, minus 8 times parent, a quarter a minus 2b, n parent, plus 3, n bracket is what? Oh boy. Okay, the first thing to do is distribute the 6 over this parenthesis and the 8 over this parenthesis. So this becomes 6/3 a plus 6 times 2b. This becomes minus 8/4 a. Watch out about the negative sign. Minus 8 times negative 2b. Okay. And then that plus 3. All inside brackets, all times 2. 6/3 is 2a plus 12b. So far, so good. Minus 8/4 a is minus 2a. Minus times 8 times negative 2 is positive 16. So a 16b plus 3. So 2 bracket 2a plus 12b minus 2a plus 16b plus 3 n bracket. Now in here, 2a minus 2a, poof, cancels. 12b plus 16b combines to 28b plus 3. All that times 2. So multiply throughout by 2. 2 times 28b plus 2 times 3. There we go. This will be 56b plus 2 times 3 is 6. 56b plus 6. Now the book often does what it calls look-alike problems, where we have the same numbers, but with some slightly different operators. 12 times 8n times 5 versus 12 times the quantity 8n plus 5. What are each of these? Okay, here. Now here we just use distribution and shuffle around the numbers, commutativity. 12 times 8 times 5 times n. Okay, 12 times 8 times 5 is 480, so this whole thing becomes 480 times n. That's this answer. Here we have 12 times 8n plus 5. We distribute the 12 over both terms. So you get 12 times 8n plus 12 times 5. Okay, 12 times 8n, 12 times 8 is 96, so this is 96n plus 12 times 5 is 60. So 96n plus 60. Okay, we have come to the end of our 2 sections for tonight. So let's call it done.